Hey guys, welcome back to my channel. Myself Shivaprasad. I hope you are all doing great. If you are new to my channel, don't forget to subscribe and don't forget to tap the bell icon so that you won't miss any updates from my end. Without further ado, let's get into today's video. In this video, we are going to solve this problem, Subarray product less than k. Let's try to understand this problem in a diagram. We'll be given one integer array something like 10, 5, 2, 6 here and k. We need to return all the subarrays that have product less than k. So how many subarrays we can generate? 10, 5, 2, 6. These are the four individual subarrays where the product is less than 100. And then 10, 5, which is one subarray where the product is less than 100. Then 5, 2, then 2, 6, then 5, 2, 6. So these are the total subarrays which we can generate. I mean, where the product is less than 100. So the total count is 8. We just need to return the answer as 8. Let's try to understand how we can solve this particular problem. This is the input array 10, 5, 2, 6. And I'm going to apply a kind of algorithm called prefix multiply. This is something like prefix sum, but instead of summation, I'm doing multiplication this time. What we can do is let's take a variable called start 0, which is initially points at 0, and end also initially points at 0. I will tell you why I'm taking this. So I start from here. So when I am here, initially my first element is getting multiplied by 1, and my second element is getting multiplied by result of this, that is nothing but 10 into 5, and my third element is going to be multiplied by result of this, that is nothing but 50 into 2, and so on. This is what the prefix sum all about. One second. Yeah. So now what I'm going to do here is 1 into 10. Okay, so as I'm saying, my start end is pointing at this. Then is 10 less than k? You are right. It's less than k. Then I'm going to consider this as a one valid subarray. Then how I can take? I can take end minus start plus 1. Okay. Of course, we need to hold a variable to track the number of subarrays. Let's assume res is equals 0. Then res is equals to res plus n minus start plus 1. What is the n? 0 minus 0 plus 1. What is nothing but 1. So the answer is going to be 1. So when we are at 10, we got an answer of 1 because 10 is a subarray where product is less than 100. Now go ahead and see. Now I come this position and I check 10 into 5, that is nothing but 50. Is 50 less than k? Yes. Then I'm going to apply the same logic and try to understand. This is 1. 1 is equals to 1 plus end minus start, right? What is the end? So end is the moving pointer here. End is nothing but 1 plus start is nothing but 0 plus 1. That is nothing but 2. What is the value? Now rest will become 3. That means there are total 3 subarrays. Okay, out of these two elements which satisfies our condition. One is 10, one is 5, and the next is 10, 5. Then we got answer as 3. It's correct. And let's go ahead and see in the next slide. 10, 5, 2, 6. Our current rest value, that means the count is 3, and we are at this position end, and start is at this position still. Okay, now let's take 10 5s are 50 into 200. Is 100 less than k? No. When we encounter this, okay, we need to check whether the start is greater than end, because our start should always be less than end, otherwise you cannot what I can say, otherwise you cannot know whether it's a valid subarray or it's not. And until we get our prefix multiply, okay, prefix multiply result is greater than or equal to k, until this condition, okay, satisfies, what we need to do? We just need to divide it by nums of start, and let's increment the start. Let's try to understand why we need to do this. So when we are at this position, what is the value we got? 100. And you know 100 is equal to k. That means it's not going to add any value to get your Subarray account, right? And the subsequent elements are definitely not going to be valid because multiplication keep on incrementing here, right? Then what we need to do? So whenever we encounter this, okay, we need to get rid of this, right? So that we can look for other combinations. So that's the whole reason why we are doing this. So when we found something is greater than, let's divide by start. That means here 100 equal to 100 divided by 10, right? Because start is pointing at 0, which returns me the 10 answer. Then I increment the start. My start now points at this position. Okay, I'm denoting with S for now. Okay, then I will check if my this part, whatever I got the result is less than K after completing this. Okay, yes, it is. This is less than 100. Then I can take one more subarray. How I can take? Res is equals to res plus end minus start plus 1. What is the end here? End is pointing at 2, start is pointing at 1 plus 1, 2 minus 1, 1 plus 1. There are two subarrays, right? And now this is going to be 5. How two subarrays? So initially we found 10 comma 5 where we generated 3. Now if we look at this subarray, we can generate two more subarrays, right? We can generate 5 comma 2 and 2 itself is a subarray because 5 is already subarray which we got in previous count only. So now if we look at this subarray, 5 comma 2 is 10 where product is less than 100, one subarray and 2 is one subarray. Then the rest become 5. Now go ahead and see the last one. We are at here end. Now what's our current prefixum value? This is 10, right? 10 into 6, that is nothing but 60, which is still less than K. Then how many subarrays I can generate? Yeah, as usual, apply the same thing. Start at 3, end at 3, start at 1 plus 1, 2 plus 1, 3. Okay, total 3 subarrays it is giving. So append that, sum that 3 to 5, that is nothing but now 8. Okay, how 3? So now from here, if you look at carefully, 5 comma 2 comma 6 is one subarray, 2 comma 6 is one subarray, and 6 itself is one subarray. Okay, so that's the reason the total count of this is 3, and which we added to this 5, that is nothing but 8. So what we are doing essentially here, so we are going through the each and every element, and whenever we are at some point, and if we know the product is less than K, then we know the previous elements product definitely going to be less than K, including the current element. So that's all we are doing. I hope you understood. If not, please look at my previous video, okay, and come back to this. You may get good understanding. Otherwise, you can please drop an comment in the comment section. I will get back to you. Let's try to analyze the time and space complexities. The time complexity is going to be big of n because I'm going to iterate through this one only once. Through this array only once. The space complexity is going to be big of 1 because I'm not taking any additional data structure rather than a constant variable. I hope you got something new today. Let's get into the coding part. Yeah, let's try to write the start. Start equals 0 and initially prefix equal to multiply, and then we need a variable called res. Initially it is going to be 0. Then for int end equal to 0, end less than nums dot len, end plus plus. Okay, then what I'm going to do, I'm going to take prefix multiplication is equals to nums of end, and I check while start is greater than end and whatever we got this prefix is greater than or equal to k. In these two cases, what we need to do? We need to divide these by start. That is nothing but prefix equals to prefix divided by. nums of start and increment the start pointer. Okay, whenever we are getting a product where it's greater than or equal to k, we are trying to, what I can say, decrease that value by dividing with the start. Okay, so that we can know about the future elements. Once this done, let's try to check whether prefix is less than k after this. If that is the case, then try to take that value like end minus start plus 1. That's it. And at the end return res. Just give a try. The output is 3, expected 8. Let's see where we are doing wrong. Initially it starts with 0, prefix is 1, res is 0, okay, and int I end equals 0, n plus plus, and nums of n will start greater than end, and prefix, sorry, start should be less than end, and prefix greater than or equal to k. Yeah, now let's see. Yeah, we got a correct output. Let's submit. Yeah, it got submitted successfully and it took 7 milliseconds, which is good. I hope you learned something new today. If not, please do let me know in the comment section, and don't forget to subscribe. I will meet you in the next lecture.